Hi, guys. Yesterday, I had the opportunity to teach microbit to fourth graders. Fourth graders who'd never seen a microbit for the first time. And I worked with a teacher, and her comment at the end was, wow, I wish I'd taken notes because I'm going to have to teach this next year and you might not be here. So, I wish I'd taken notes so that I had that because I'm not going to remember what we did. And I figured, you know what? I'll make a video. So, one, she can have the notes. There you go. But also for myself, so that I would have notes. And then, yay, if you want to use it too, that's great. I think the BBC Microbit's an awesome vehicle to help get kids excited about coding. So I'm really excited to go make a video and talk about it. Here's what we did for our, what we call a quote unquote run of show for a simple introductory 50 to 60 minute intro to microbit. First, we did kind of a story time setup. So the kids are on the floor and we had them discuss the parts of a computer between each other for a couple minutes and then talk to us about what they talked about, right? So for example, people might say, I know that there's a mouse and I know that there's a screen with LED and with pixels, or that there are connectors, there's cables, things like that. A critical thing to do at this point is to remember, one, the kid's name, and then also a word, a keyword, like pixel or breadboard or cable or processor or something like that. And that way, when you're going through the hardware part of it, when you talk about it, right, you can say, oh, remember when Anna talked about pixels? The microbit has 5 pixels where your computer or your TV might have 1,000,000 pixels, but you get to decide what you want to do with these 25 pixels. And then we jump right into an activity. And that first activity is to have the kids navigate over to makecode.microbit.org. So they got to open the computer, they got to log in if they have a login, and then they got to go and makecode.microbit.org and then raise their hands when they're there. And then they should have that page that says, here's the front panel with the new project. That's where they want to get to. Raise your hands when you're done. And then once everybody raises their hands, then you turn back to your teacher and you say, okay, well, we're going to walk through. I'm going to show you how to do this. The first thing you want to do is walk through the basics of the editor. That'd be that kind of 3-panel display. And I'll do this in this video. Don't worry, I'll show you. And then do a simple flip card example, and I'll show you how to do that. And then you're going to have the kids go do that. So then again, back into the activity, right? They're back and doing stuff again. Once they've got that, then you talk about, okay, well, what's next? What's next is putting it on the microbit. And so you go and you show how to go and download the code to the microbit. And this is the sticking point right here. So this is where you're going to want to spend a little bit of time. And this is why you need a bunch of proctors, because they're going to get frustrated and you got to tell the kids first, this is going to be tough. This is the toughest part of this, but we're going to help you. And then once they've successfully downloaded the code and everybody can see theirs, then you get into the next activity. And the next activity is basically just building on the 2 cards and turning it into like a 7 or 4 to 7 card story, right? You're going to have the kids tell an animated story in 7 panels. And once they've got that, then you're going to do like a basic kind of story time, like you'd see in any kind of library setting or something like that, where the kids sit around. But in this case, instead of telling some story out of a book, you're telling their stories, which is super cool. So you basically connect the microbits one by one into your computer just to give it power. And then you see, you hold it up and you'll see the animation, and then kids immediately will recognize theirs and then kind of raise their hands and they'll talk about what the story was and what it meant to them. And it's super fun. I'm telling you, that is the best part of it. And you're going to have a blast. So I've been doing this for a little while with myself and with my companies. What I can tell you is here's some things that are different between the way that you would present stuff to, say like a meetup or, a conference or something like that, and the way that you're going to present to 4th grade kids. One, dump the elaborate instructions. I'm telling you, they don't care what it's like to be a software engineer. They don't care about, the philanthropic reason why you're there, sharing your talents with them and blah, 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 blah. They don't care about you're thanking your job. Oh, thank my employer for being so nice, for letting me have this time, blah, 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 my boss. Or, hey, you should really work with such and such. No, it's 4th graders. They're not going to work at any company for a long time. You're not recruiting. They don't care about job titles, titles. They don't care about any of that. Even job diversity. Diversity is great, but show them diversity by being diverse. Like just, All right. And also the QA at the end. Just dump that as a formal thing. I know that's like, oh, everybody's got, QA 5 minutes, blah, blah, blah. Don't. Who cares? If the kids come up and ask you questions, and they will, then that's cool, right? But you don't have to force them to ask questions. And then also, and this is critical, really, really critical, don't do anything on the keyboard or mouse or screen with your hands for them. Walk them through it. That's really critical. If you see something that you don't understand or don't know how to do, because this is and this always happens around download, like a computer is set up slightly differently and you have to walk through it. That's cool. Go figure it out, but then immediately have them go do it. Not just don't figure it out and then walk away, because then they're not going to have learned anything. They need to get that muscle memory. And I mean literal muscles in terms of the fingers on the keyboards or fingers on the mouse, moving stuff around. They've got to learn that. And then what's some stuff that was good? So along the way, we've learned that interactive teaching. So that means when you're up at this front of the stage, and in our area, Beaverton School District, they call this sage on the stage, right? When you're up there presenting in front of kids, you want to make it interactive, right? You want to ask them and then talk about it. Or when it comes to and remember I said names and words, remember those, right? When you say, oh, and Anna talked about this and Sean talked about that. And so and engage with them, make it interactive, change how you're doing things based on what they're telling you. And also only spend about 20% of time on that, right? You want them to be doing, you want the activities to be the central focus of the whole thing. And during those activities, your job is to guide. It's not to do. It's to be there and help them express their creativity through that mechanism. And also, we found that emphasizing on being a creator, that you are creating things. There are people that created Fortnite, and there's people that created Minecraft. You too can be a creator, and we're helping you build your creative ideas through the mechanism of these technologies. So about the hardware. Don't go super in depth with this, but just to familiarize themselves with, hey, what's this thing, right? You bought this thing. What is it? When you talk about it, you point it at them and you say, well, what is this? What do you see on this? And the first thing they'll invariably see is the 5x5 array of pixels. And you can talk about how that's like a TV, and where your TV has X amount of, millions of pixels. Your microbit has 25, but you get to decide what you do with those 25. And that, they're only red. And the next thing you're going to notice are the buttons. You can talk about how you could use them like a game. For example, you could have a Tetris game where you're going to move the block from left to right using A or B. And then you can also do like a combo, like A plus B. Remember, like you're doing a fighting game, it's like combo kick, A plus B. And then the edge connector. And some kids will notice that. It looks like a ruler. You'll hear that. You can talk about how that allows them to connect to things. Like, for example, a set of headphones. You can connect using alligator clips. You make a big kind of jaws in your hand. These are things that connect between two pieces of electronics. And you can put one alligator clip on the edge connector and another alligator clip on your headphones. You can do that another time, and you can get sound out of it. It doesn't have a speaker, but you can use your headphones with it. So then on the back, and I spend even less time talking about the back. The back has obviously the reset button. They'll talk about that. You can restart your app using that. The micro USB connector where you connect it to your computer, and that's how you get your code onto it. Power connector, how you can use that to put a battery pack on it, and it's self-contained at that point, and you can just put it anywhere you want. And then a little bit of time maybe about the accelerometer and the radio. You're not going to use them, so it doesn't really make much sense to talk in depth about them, but just to show that, it has a lot of cool stuff. It's very similar to, like, for example, like you can equate the accelerometer, which allows you to figure out the roll and the pitch and the yaw of the device, back to like a cell phone, like the orientation of the phone. So let's talk about the actual activity. And we'll have a look. This is the makecode.microbit.org. This is where they're going to go to as the landing page. So we're going to start with adding a new project. And then this is where you talk about that you've got 3 panels, right? You got the simulator over here, and that's going to show, and you hold up the microbit and you say, look, this looks exactly like a microbit, right? So this is going to show what the microbit's going to do with your code. Talk about over here in the drawers section that this is all of the functionality of the microbit is in here, and you can drag and drop it onto this area, which is the play area. This is where their code is going to go. And then you can talk about on start and how that's the startup stuff, and then forever. And I'm not really sure if that hit home at all, the difference between the two, because in this example, you don't even really need on start, and you can just get rid of it if you want. The example is we're going to go over here and take show LEDs and talk about how first you click on this and that brings up the panel. You can drag this drag it out of there, and then drop it. And you can drop it when you see that yellow indicator, and you hear a nice gratifying little snap when it goes in there. And so what I like to do is start with just, okay, a smiley face, something like that. Very, very simple. And you can see over on the simulator, you actually see the smiley face. Ooh, kids get a little, ooh, that's cool, that's neat, I like that. Right? And then, okay, well, what if we go and add another one? And we'll go and we'll make like a frowny face, smiley face and frowny face, right? And now you've got an animation. You can talk about how this is the same kind of animation you get in like a movie. This is how they do that. And they immediately kids be, oh, that's really cool. I did find that actually being a little bit more positive and doing like instead of frowny face, happy face, having this kind of icon where it's like nom 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 kind of thing. It's a little more enjoyable. Okay, and that is the extent of it. I'm telling you, like that. So this is the sum total of the level of the code that you're going to be doing. It's going to be this first, and then basically just 4 to 7 panels they're going to use to tell their story. So then you get to the hard part. So you've gone and you created your code. Everybody now has gone and built it. And okay, now we got to go and get it on a microbit. Okay, so what's next? This is the trick. So you tell the kids this may be tough, may be frustrating. Don't get frustrated because we are here to help you. So hit the download button. And then it really depends on the platform. Like, is it a Windows box? Is it a Mac? Is it a Chromebook? All of these experiences are going to be slightly differently. They're going to work slightly differently. But what I find works is you click on show in folder or finder, whatever is appropriate to your platform. And then you're going to want to just drag onto the microbit like that. Now sometimes a save dialogue comes up and other things. You kind of got to roll with the punches. Another thing you like to talk about is how you watch for that flashy light. Because when it's downloading, a little yellow flashy indicator will happen, and you've got to watch for that light because that light's going to tell you that good things are happening. And then once it's done, and you can show them that indicator, you flip it around, and they'll see that what was on your screen at the front of the class is now on the microbit. And that's awesome. And they're whoa! And at that point, you will not want to. There's no holding them back. They're going to do it. And so all you got to do at that point is just guide them in that process. Okay, so let's talk about the things that worked. Again, using their names and their words, super critical to creating a respect between both of you and saying, I'm actively listening to you. Pairing kids together works really good because when they run into problems, they can kind of work through it together and teach each other about it, and that's great. In particular, when you do the 2-panel animation thing, encourage them to have one kid do one panel and one kid do the other panel, and that splits the keyboard time. Sometimes you'll get kids that will dominate the keyboard and and the other kid won't learn much, right? You really, really want physical contact between each kid and the keyboard and the mouse to get this going. You also want a good, decent ratio of kids to proctors. At least in my classes, I think we had like 5 to 1, 4 to 1 in that range. This is really going to be all about that download section. You got to have enough proctors so that like the kids aren't waiting a ton for you to help them solve their problems. Another thing, some kids are just not going to want to do the LEDs. That's fine. They're probably going to want to do music. And if a kid's super adamant about that, don't get in the way. I mean, what's the point? The point is to teach them and to get them excited about a technology and using technology to create an art. And if that art is sound, if that art is LEDs, who cares? The fun is in engaging them and in opening their minds to the idea that they can go and be technology creators as opposed to consumers. And I also find that relating it back to art, a lot of these kids and at these age ranges, they do a lot of art, sometimes it's externally, sometimes it's in the school. But relating this back and saying, look, this is technology as a new medium, right? Some people use paints. We use technology to create art. And then that story time part, that was phenomenal. The idea that they would create the story through this technology that they'd only learned 20 minutes ago, and they're creating stories with it. How cool is that? And then finally, I would say, if there is a ton of interest in music, right? That music panel is just like screaming at them like, I gotta do music. Then that's cool. Let me talk about how we talked about that. So back here with the music stuff, I just went and dragged a music item. And what that does is that actually brings up right away the simulator that shows the wiring diagram of how you'd actually connect this to a set of headphones. And so he can talk about, well, here's what you do. You go and take an alligator clip, and you guys have these alligator clips, and then you connect them to the headphones, just like it's shown here. And that, I think, was one of the coolest things about this particular makecodemicrobit.org setup, is it actually shows you how to do wiring. You're not only learning software, you're learning hardware all in one place. Awesome. And so, encourage them to do that. But then say, maybe in the lesson that follows, we'll do one specifically about music and kind of diffuse that whole thing of music versus that. I mean, ideally, you'd like most of the kids to create the story that will enable you to do a good story time. Okay, so finally, I want to talk about what to practice. I know that sometimes to feel comfortable going into these situations, you want to do a lot of practice. I would encourage you to strongly practice downloading the code. Try and, if you have someone that has a Chromebook, if you have a kid in this class, if you have access to a Chromebook, but you don't have one at home or something like that, figure out a way to get access to it, because there is a different experience between the two. A lot of these Chromebooks have touch. And while you can select stuff with a touch, you can't drag stuff with a touch on some of them. So just understanding that, so you're not going to be freaked out when you go through downloading the code, because that is the critical piece. So do everything you can to practice downloading the code so you have that rock solid. Okay, well, that's it. That's my spiel about how to teach kids in the 4th grade how to do microbits. As a YouTuber, I guess I got to do the usual thing of, I'm sorry, asking you to subscribe or like my channel if you like this video. All right, guys, thanks, and I'll talk to you later.